Hi everybody, welcome back. In this session, I'm going to discuss worksheet questions based on laws of motion. Let's see. A spherical bob of mass m is equal to 250 gram. It's not an SI unit. You need to convert into 10 to the power of minus 3 per kg. Now, length of the string 50 centimeter. It is also not an SI unit, 10 power minus 2. Then the bob is rotated in a horizontal circular path, and with a vertical axis. Okay. Then maximum tension is 72 Newton. Okay. The maximum possible value of angular velocity omega is equal to question mark. Centrifugal force acts like this, whose expression is mr omega square. So that balances tension. Maximum tension causes maximum angular velocity. So mr omega square is equal to T. Then omega square is equal to T by mr. And omega is equal to square root of T by mr. That is equal to square root of T, tension, 72 by m, 250 into 10 to the power of minus 3 into r. R is nothing but length of the string. So 50 into 10 to the power of minus 2. So omega equal to, let me take another color. Omega is equal to 72 by this 10 power minus 2 and this 2 zeros will go. So into 1000 will be there, of course 10 power 3 only I'll write. 25 5s are 25 into 5s. Okay. 25, 40, blah, blah, blah. So hardly 24 it will come, right? So answer is B. Yeah. Okay, next. A constant horizontal force of magnitude 10 Newton. Constant horizontal force of magnitude F equal to 10 Newton is applied to a block A, okay, and produces an acceleration A is equal to 20 meter per second square. If this block A is then kept against another block B, okay, of mass 1.5 kg. So of mass 1.5 kg, mass of block B is equal to 1.5 kg as shown in the figure, and force F dash equal to 20 newtons is applied. Now F dash is equal to 20 newtons is applied. Find the force on the block B. Neglect friction. Okay, mass MA he didn't give, that first you have to find out. MA is equal to F by A. F is equal to 10 newtons, acceleration 20, so it is 1 by 2 kg. So first mass is 1 by 2 kg. First mass 1 by 2 kg. Second mass 1.5 kg. And he is asking contact force. So contact force is equal to mass to be pushed into acceleration. Contact force is equal to mass to be pushed into acceleration. So mass to be pushed is 1.5 into acceleration is applied force by total mass. 1.5 applied force 20 newtons by total mass is 1.5 plus 0.5. So it will be 1.5 into 20 by 2. So 1.5 into 10. How much? 15 Newton. Yeah. Yes. Next. Next question is, consider a frictionless ramp. Consider a frictionless ramp on which a smooth object is made to slide down from an initial height h, the distance d necessary to stop the object on the flat track if the quotient of friction is mu. The symbol is missing. Kept at the ramp at the end. Okay. Consider a frictionless ramp. This is a frictionless ramp. Okay. This is frictionless. And at the bottom, slide down from an initial height h. It is h. Now here is some distance d, which is rough. This is rough. How much is needed to stop? The stop distance or the work done is equal to frictional force. Work done is equal to frictional force into displacement. Frictional force into displacement. I can call it as S. That is equal to loss of kinetic energy of mv square. That is nothing but mgh. So mgh converted into kinetic energy. That kinetic energy should be cancelled by work against friction. So mgh is equal to fs. Now here mgh is equal to f value is mu n mu mg into distance d. So mg gets cancelled. This also gets cancelled. So h is equal to mu d. So he is asking distance, I think, right? Distance, yeah. Distance d is equal to h by mu. H by mu. This is not L, actually by it is. Done. Next. A time varying force acts on a ball of mass 100 gram. Force F is equal to time varying force. He didn't mention. Okay, 20 kilonewtons is the maximum one. Okay, let me write first the given one. Mass M is equal to 100 gram for 2 milliseconds. For 2 milliseconds, time is equal to 2 milliseconds. Yeah, the force versus time graph is shown. See, millisecond should be noticed carefully. Gram is also noticed carefully, as shown in the figure. If the initial velocity, initial speed of the ball is u is equal to 10 meter per second, then speed of the ball after t equal to 2 milliseconds is final velocity equal to area of ft graph will give you area ft graph will give you change in momentum mv minus u, right? Change in momentum. So force area of ft graph, area only directly we can calculate. What's this area? Half into base 2 into 10 to the power of minus 3 milliseconds, right? That's why half into base into height 20 kilonewtons 10 to the power of 3 is equal to m mass 100 gram 100 into 10 to the power of minus 3 into v minus u. V value we have to find. U value 10. Yo. So here 10 power minus 3 10 power minus 3 will go. This 2 will go. Here 20 will be left. That is equal to 100 into 10 power minus 3. 100 into 10 power minus 3. Okay, into 10 to the power of minus 3. I kept like that only. V minus 10 I wrote like the same. This is 0.1 or 1 by 10. 1 by 10 will go this side. 200 it will be. 200 plus 10 is equal to V. So V is equal to 210 meter per second. Yo. Yeah. Concept try to understand from my lecture, and the simplification part you too can do on your own in a better way because you're a mathematics student, right? Yeah. Next, a system as shown in the figure is in equilibrium and is at rest. Okay. The spring and the string are massless. Okay. Now the string is cut as shown by the scissor. Acceleration of the masses 2m and m just after cutting it will be, okay, see here, acceleration is equal to unbalanced force by mass. This is Newton's second law. Yeah, acceleration equal to unbalanced force by mass. So acceleration of 2m, first order you need to check. See, g is there, g by 2 is there, g by 2 is there, g is there. See, order is important. That means 2m's first you need to think. 2m's you have to think first. 2m is balanced now. Suppose if it is cut, which force is unbalanced for 2m? For 2m, the unbalanced force is mg. mg is unbalanced. Previously mg is pulling down. That is removed. So mg is unbalanced. By mass is 2m. So it will be g by 2. As the body Here mg is there, though, so here it will be balanced. If it is removed, so unbalanced force is in upward direction. Unbalanced force is in upward direction, so it will be upward. Next, acceleration of m. Unbalanced force is mg, which is acting downward direction, by m. So that will be g downward direction. Okay, yeah. So first g by 2 up, next g down. Yeah, g by 2 up and g down. Next, a block A of mass 3 kg rests on another block B of mass 7 kg. The coefficient of friction between A and B is 0.4. Why everything I'm typing here? Yeah, the coefficient of friction between A and B is 0.4. The coefficient of friction between B and the horizontal floor is 0.55. Find the force of friction between A and B when a horizontal force of 50 Newton is applied on a block B. First, let us picturize the story. Block A, B. Let me draw with another different colors. Block A, B. First one block is there, over another block is there. Let me take another color. Yeah, so totally blocks. A block A of mass 3 kg rests on block A 3 kg, resting on which one? Block B of 7 kg. This is block B 7 kg. Okay, okay. Your wish. Quotient of friction between A and B is 0.4. Here mu is equal to 0.4 and here mu is equal to 0.55. Okay. Now force on which? Find the force of friction between A and B. Okay. When a horizontal force of 50 Newton is applied on B, 50 Newton is applied on B, F is equal to 50 Newton. What is the maximum force taken by A? Mu mg. Mu n, that is equal to mu mg. Mu n is equal to mu mg. That is the maximum force on A. Maximum force on A. That is equal to mu is 0.4. Mu is 0.4 into 0.4 into m value 3 into g value 10. So it will be how much? 4 3s are 12 Newton. Maximum force taken by it is 12 Newtons. Okay. Next, mu mg is equal to 12 Newtons. Now we are going to calculate. Next, we are going to calculate maximum frictional force F maximum for B, that is equal to mu n. Mu value 0.55 and n value is 7 kg, 3 kg. Total normal reaction force on block B. So 10 kg, 10 into G is 10. So it will be 100. 100 means 55 Newton. 55 Newton. A. Applied force is 50 Newtons. 55, huh? 100. 55, yes, not 550. 55. So here applied force 50 Newton. Applied force 50 Newton, which is lesser than F maximum force on B. So B do not move. B don't move. As B won't move, obviously there is no relative motion between A and B. And there is no tendency also. So no tendency of motion. No tendency between A and B. So obviously frictional force between A and B is zero. Whenever there is a tendency of motion, then only force comes to act. Okay, next. An infinite number of masses are placed on a frictionless table. They are connected via massless strings. Okay, like this, fine. And connected to a mass m and hangs over a massless pulley. Acceleration of the hanging mass is acceleration of the hanging mass. They're all massless, huh? Once again, an infinite number of masses are placed on a frictionless table. So acceleration A is equal to applied force by total mass. Applied force, that to unbalanced force. What is the applied force for the motion? mg by total mass. What is that? m plus m by 2 plus and so on, whatever is there. So obviously this will be A is equal to mg by m can be taken common and cancelled. So 1 plus 1 plus 2 plus and so on, whatever this expression. 1 plus 1 plus 2 and so on, this is all nothing but E, right? So gets cancelled. So G by 1 plus E, G by 1 plus E is the answer, not C. I need to change it, okay? Otherwise we have to start from masses follows a sequence m by 2 onwards, okay? This m we shouldn't consider. This m we shouldn't consider. Then obviously follows a sequence of m by 2, m by 6 and n factorial. 1 factorial automatically this one, 2 factorial is this, 3 factorial is 6 and so on. So this block shouldn't be. Then if this block is present, G by 1 plus E. If this block is absent, then G by E will come. So as I'm changing the question, so I don't want to change the option answer here, then you can take this m won't be m plus m by 2 plus and so on. So this won't be. Then obviously it is E only. So G by E is correct answer. If m is present, G by 1 plus E. If m is removed there, then G by E only, correct answer. Next, let us learn. When a bullet is fired from a rifle, its momentum becomes 20 kg meter per second. 20 kg meter per second. Okay. Next, if the velocity of the bullet is 1000 meter per second, what will be its mass? M is equal to how much? Mass m is equal to how much? Momentum p is equal to mass into velocity. Mass m is equal to p by u. P is 20 by u is 1000. This will give you kg. Okay, so 20 into 10 to the power of minus 3 kg, which is nothing but 20 gram. So you can select the option from here. Yes. Next, a block of mass 8 kg, m is equal to 8 kg, is suspended by a rope of length 3 meter from the ceiling. Force of 40 newtons is applied horizontally to the block. The angle made by the rope with the vertical in equilibrium is, the story is like this. This is the block. The block is applied with a force F horizontally. Okay, F I will write here. So mg I will write here, mg, and this is theta. Then he is asking about that theta. You can take tension and you can resolve it into components. I can use the direct formula, but I want to teach. So this is tension, this is tension T. If this will become theta, and this will be T cos theta, and this will be T sin theta. So he is asking which one? Angular. Okay, fine. Then T cos theta balances which one? mg. And T sin theta balances which one? T sin theta balances in equilibrium. T sin theta balances F. And dividing one with other, 1 by 2, if I divide this equation 1 and this equation 2, implies tan theta equal to F by mg. So what is the applied force? 40 Newton. What is mg? Mg is 8 into 10. So 0 will go. This will be 1 by 2. Theta equal to tan inverse 1 by 2. Tan inverse 1 by 2. Yo. Okay, next. 3 blocks are connected by massless strings on frictionless inclined plane. Yes, like this, as shown in the figure. 3 kg, 5 kg, 8 kg, 30 degrees inclination. A force of 104 newtons is applied upwards. 104 newtons is applied upwards along the incline to mass m3. Okay, causing an upward motion in the blocks. What is the acceleration of the blocks? Acceleration A is equal to net force for the motion by total mass. Mass is a scalar quantity, you don't have right to resolve it, but weight is a vector quantity, you can resolve. Yeah. Net force is, you have to think like this. Applied force is 104 newtons, no doubt, applied force. Then what about the downward force of mg sin theta for everything? For every mass there will be mg sin theta downward. So net force will be upward force minus, I'll write first like a formula, later I'll substitute so that you can understand comfortably and you too can simplify on your own. So upward force minus downward force is m1 g sin theta, m2 g sin theta, m3 g sin theta, they can be taken common, g sin theta, by total mass. Total mass is m1 plus m2 plus m3. Let me write A is equal to 104 minus 3 plus 5, 3 plus 5, 8, 8 plus 8, 16. I'm writing directly 18, g value 10 into sin theta value, sin 31 by 2. Oh my goodness. So next, m1 plus m2 plus m3, 16. Wow. This will go as 8 times. Always don't touch zeros. So simplification will be easy. 104 minus 80 by 16. So it will be 24 by 16. 24 by 16. Even points are there. Okay. 2 table, 4 table. 4 table? 6. Yeah. 4 table? 4. Okay. Again 2 table? 3 by 2. Again will be 1.5. We have the answer with this. So acceleration A equal to 1.5. This mathematical simplifications, you people are strong enough than me. An object requires 500 Newton force to be pulled up on a 30 degrees frictionless smooth inclined plane at constant speed. The weight of the object is equal. For the constant speed, acceleration 0. V constant. That means acceleration 0. That means net upward force is equal to net downward force. Implies net force is 0. Net force is 0. That is the logic. That's why on an inclined plane, body is there. Upward force needed F to maintain V constant. Okay. Downward force is mg sin theta. So mg sin theta equal to F. Mg sin theta equal to F. Why? Because upward force must be equal to downward force to have constant velocity. Now he is asking weight of the body. mg is itself weight. W into sin theta. Sin 30, yeah, is equal to F 500 Newton. So W is equal to 1000 Newton. This is the answer. Yeah. Next. Cricket ball of mass m is equal to 50 gram. Cricket ball of mass m equal to 50 gram. Having velocity u is equal to 50 centimeter per second. Be careful at units, Chotus. And is stopped in 0.5 seconds. Time interval 0.5 seconds. The force applied to stop the ball is F is equal to how much? Change in momentum by time. F is equal to change in momentum by time. Change in momentum mu is initial momentum, final 0. So change in momentum is mu by t. So F is equal to m value 50 into 10 to the power of minus 3 into u value 50 into 10 to the power of minus 2 by time 0.5. So this 0, this one gets cancelled. 5 5s, 155 will go here. 5 into 10 to the power of minus 3 by 0.1 will be there. 1 by 10. So this is 50 into 10 power minus 3 Newton. So option 0.05. Yeah, B option will come there. 0.05 Newton, I too will write. Next. In a rocket, fuel burns at a rate of 1 kg per second. Fuel burning rate, dm by dt, we have to consider. That is 1 kg per second. It's SI unit, no issue. This fuel is ejected from the rocket with a velocity 60 km per second. U is equal to 60 into 10 power 3 meter per second. So see, I'm converting units rapidly. The force exerted on the rocket F is equal to how much? F is equal to Ru. This is rocket R, rate of R. Ru. R is dm by dt. That is 1 kg per second. That is SI unit only. This is U, 60 into 10 power 3 meters per second. This is also proper unit only. So final answer 60 into 10 power 3 Newton or 60 kilonewton, whatever. So 4 zeros are 1, 2, 1, 2. 4 zeros yo. Next. Two masses M1 and M2 are arranged as shown in the figure. Let A be the magnitude of the acceleration produced in M1. Okay, M1 is on a horizontal surface, M2 is on an incline. If the mass M1 is doubled and that of M2 is halved, okay, a second case it is, M1 is doubled, M2 is halved, then the acceleration of the system is. First we will write what's the given acceleration. What is the given acceleration? Given acceleration A is net force is m2g by total mass is m1 plus m2. This is, let me write capital only, this one also, everything in capital. Why should I change? So this is first one, first story. Now second story is, now he said he is going to change the things. What is that? m1 is doubled. So this one going to become 2m1. And m2 is halved. This will become m2 by 2. In that case, then the acceleration of the system is, now acceleration A dash is equal to, same story, m2 by 2 into g applied force by total mass, 2m1 plus m2 by 2. This is to be simplified. So A dash is equal to m2g by 2 km into, this is 2m1 plus m2 by 2. Almost all same I wrote, nothing I changed. So that's why equal to, suppose in LCM I took, what happens? m2g by 2 2s are 4, 2 into 2 2s are 4m1 plus m2 will come. And by 2 is there, by 2 is there, I am taking LCM, this 2 will go. So A dash is equal to, what is m2g from 1? m1 plus m2 into m1 plus m2 into A I can write, m2g by, this is 4m1 plus m2. So such option we need to select. Option A. Correct. Done. Okay. What I did, since what you call m2g is equal to m1 plus m2 into A from equation 1. That's why. Okay. Next. Or otherwise you can take it as the second equation and divide first equation with the second equation, then you can correlate. That is also one of the method. Next. A person of mass m is equal to 90 kg, m equal to 90 kg, standing on a smooth horizontal plane of ice, throws a body of mass 10 kg. She is throwing 10 kg, okay, horizontally on the same surface. If the distance between the person and the body after 10 seconds is 10 meters, then kinetic energy of the person is, so m is 90 kg, small m is 10 kg. Here the person throws a body, so goes how much, the body is on, also on the surface, comes how much distance, 10 meters. In how much time? T equal to 10 seconds. That means with which velocity the person throwed this body, that velocity v is equal to distance by, because it's smooth, distance by time, so that is equal to s value 10 by 10, so that equal to 1 meter per second. The body is thrown with 1 meter per second. Next, from law of conservation of linear momentum, the momentum of the body is equal to momentum of the person, with which velocity, with which momentum I have thrown. Suppose if you are firing a bullet, then momentum of the bullet equal to momentum of the gun, right? Like that. If I'm throwing a body, that means the body's momentum and the person's momentum will be same. Person momentum, body momentum will be same. Person momentum m, okay, person momentum. Actually, I no need to calculate person momentum because he is asking kinetic energy, right? So momentum of the body is equal to mv, person momentum, that is equal to m value 10 kg, yeah, okay. Velocity 1 meter per second, so that equal to 10. Then kinetic energy Ke is equal to p square by 2m. Momentas will be same, no? That's why. So p square 10 into 10 by 2m, 2 into m value. Whose kinetic energy you are calculating? Kinetic energy of the person you are calculating. Kinetic energy of the person mass 90. So it will be 0, 0 will go. This is 10 by 18, right? So options are in a different ways. So 2 table again will go. So almost all it is 10. This is, you can take as 20, suppose 1 by 20. 1 by 20 is 0.05. Okay, so it comes like this. Yes, 0.55. So it can be rounded to 20. Then it will be easy to assess the option, right? Yes, you are right. So here, hey, don't waste your time in finding the velocity of the person, because we want kinetic energy. Kinetic energy p square by 2m is also there. This is mass of the person you have to take, because kinetic energy of the person. Momenta will be same. See, p square by 2m if you take, then kinetic energy of the person will come. Kinetic energy of the person will come. P square by 2m if you take, then kinetic energy of the body will come. That means whatever the thing, that p will be same, only masses will change. That's what I want to say. Okay, next we will enter into another question. Maximum value of the applied force F. Maximum value of the applied force F, such that the block is shown in the arrangement does not move. It shouldn't move. Then maximum value is maximum value. Suppose let me take up, if the picture is somewhat bigger, then I might have used that only. But here the F is applied like this. F is applied like this. F. So I would like to take extended. This is F I want to take. Then this can be resolved into two components. It's pushing, right? Yes. And the angle is this is 60. This is 60. Then this will be 60. So this is F cos 60. This is F sin 60. And this will be normal. Here is mg also. Okay. So friction will be back. So here is friction. So not to move. So friction must balance F cos theta, right? What is frictional force? Frictional force is mu n. Mu n. N is friction force is mu n. What is n? N is equal to mg plus F sin theta. That is equal to F cos theta. If you know the simplified direct formula, you can use directly. Okay. So it is mu mg is equal to F cos theta minus mu F sin theta. So F is equal to mu mg by cos theta minus mu sin theta. So F is equal to mu mg. Where is mu? Is it given? Yeah, 1 by 2 root 3 is given. 1 by 2 root 3 into mg. M value, maximum value of the applied force, root 3 kg, he only gave root 3 kg into g by cos theta, cos 60, 1 by 2 minus mu 1 by 2 root 3 into sin theta, sin 60, root 3 by 2. Oh, in a better way he gave root 3 will go. Okay, anyway, this can be simplified by you, not by me. So that can be 20 Newton. Normal simplification only, right? You can do it. Next. Sand is to be piled up on a horizontal ground in the form of a regular cone. Okay. A fixed base of radius r. Coefficient of static friction between the sand layers is mu. Maximum value of the sand can be piled in the form of a cone without slipping the ground is these options we have to do from them. So in this case, maximum volume of the sand can be piled up. Maximum volume, V max. Maximum volume is 1/3 pi r square h maximum. So that we have to calculate. Okay, fine. H and R relation, because options are in R. H and R relation. We will see like this. If it is theta, first this is H, this is R, and yeah, this is suppose say theta. Then what is tan theta? Tan theta is equal to, I'm not taking angle here. Why? Because if I took the angle here, then tan theta is equal to mu, right? That's why tan theta is equal to mu, angle of the plank, like that. That is equal to H by R. So H is equal to R mu. I can use H is equal to R mu. If I write 1/3 pi R square into R mu. So R mu, not U, not omega, R mu. So R mu. This will be pi mu R cube by 3. Such option? Mu pi R cube by 3, option D. Okay, let's go to next question. Yeah, two situations, figure A and B. Okay, each case masses are given, accelerations even it. We need to find out accelerations. Okay, suppose first case, acceleration A1 is equal to net force is m2g by total mass is m1 plus m2. What is m2 value? 4, g value 10 by m1 plus m2, 3 plus 4, how much? 7. So 40 by 7. This is first one. So option only C is there. Let me check. Yeah, but we have to do the other one also. A2 is equal to acceleration m2 minus m1g by m1 plus m2. So A2 is equal to m2 4 minus 3 into g by m1 plus m2 3 plus 4. So A2 is equal to 1 into 10 by 7. So 10 by 7, correct only. Yes, C options, and respective units are meter per second square. Okay, next. A particle is placed at rest inside a hollow hemispherical radius r. The quotient of friction between the particle and the hemisphere is 1 by root 3. Maximum height up to which the particle can remain stationary. This is the trough, hemispherical. Maximum height, suppose it's radius, and it came up to here, and up to here it is remains stationary, suppose. Then I'm doing the derivation once again for you, because I'm taking this as an opportunity to teach. Yeah, its tendency is downwards, so friction will be upwards. This is friction. This is mg sin theta downward force, mg sin theta downward force, and it is theta. And this will be mg cos theta, mg cos theta. So here will be the normal n. So friction can balance F is equal to mg sin theta. So it remains stationary. Next, F is equal to mu mg cos theta is equal to mg sin theta. Yes, what is he asking? Mu value is 1 by root 3. mg gets cancelled. Height he is asking. Okay, no problem. Height is this one he is asking. This height he is asking, h. So first mu value is 1 by root 3. 1 by root 3 is equal to tan theta. Tan theta 1 by root 3 means theta is equal to 30 degrees. You are right. Now h is equal to r of 1 minus cos theta. h equal to r of 1 minus cos theta. R is the radius. In terms of r only the option. 1 minus cos 30. Cos 30 value is root 3 by 2. 1 minus root 3 by 2. Don't expect always numbers will be good. Okay. So it is the answer. Next. 100 Newton force is applied to 10 kg block as shown in the figure. Okay. Then the acceleration of 40 kg slab is, the acceleration of 40 kg slab is, so we want acceleration of 40 kg block. Yeah. Let's switch on some more lights for better. Okay, yeah, I think I'm visible good now. Acceleration of 40 kg slab. Okay, first the force transferred to 40 kg is, if there is a relative motion, then only kinetic frictional force will be transferred. If it is a static, there is no relative motion, then static frictional force will be transferred. So that we have to check. For that, maximum force that can be transferred is equal to mu n, which is equal to mu mg, which is equal to 0.6 into 10 into g value 10, that is 60 Newton, which is lesser than the applied force of 100 Newton. So there is a relative motion. So it moves. As it moves, friction will be kinetic friction. F can be kinetic friction. That kinetic friction is equal to mu k n, that is equal to mu k mg, which is mu k mg is 0.4 into 10 into 10, which is 40 newtons. This is the frictional force transferred to the lower block. The acceleration of lower block is equal to frictional force by mass. Frictional force is 40 Newton by mass is equal to 40 kg. Okay, 40 kg. So it will be 1 meter per second square. If I take g value 9.8, then I'll get 9.98. Okay, so if you want, you can do like that. Anyway, I too will write one step, because then only you people will satisfy. So mu k mg by m, that is 0.4 into 10 into 9.8 by 40. Then obviously 0.98 will come. Okay. Yeah. Next. Second square. Next. A man weighing 60 kg is in a lift moving down. Then apparent weight is equal to force exerted by the man on the floor is m of g minus a. Lift moving down, m value 60 and acceleration 1.8, 9.8 minus 1.8, that is 60 into 9.8 minus 1.8 is 8.0. Yeah, 480. Yes. So next, the tension in the spring is, okay. So whenever two ends are pulled like this, the tension will be F1 plus F2 by 2. F1 plus F2 by 2. F1 plus F2 by 2 is the tension. Tension T is equal to 5 plus 5 by 2 is 5 newtons. Yo-yo. Next, when a body slides down on inclined plane with coefficient of friction mu, then its acceleration will be, body sliding down, then its acceleration will be, downward force is mg sin theta, upward force is friction, then net force is equal to mg sin theta minus mu mg cos theta. This is net force. Net force by mass will give you acceleration a. So a is equal to g into sin theta minus mu cos theta. kinetic friction. Yes. Which option? Option A. Yeah. Next. A body of mass m hits normally a rigid wall with velocity v and bounces back with the same velocity. Then change in momentum 2mv. The impulse experienced, okay, change in momentum is equal to 2mv, that is equal to impulse experienced. Impulse is equal to change in momentum. Force into time is the impulse. That is nothing but change in momentum. That is 2mv. So, yeah. In the arrangement shown in the figure, okay, the quotient of friction between the two blocks is 0.5. Okay, mu is equal to 0.5 or 1 by 2. The net force in horizontal between the two blocks is net force, okay, as it is applied with 20 newtons of force, is a bigger one. So body moves in the right side direction. So what is the force transfer to the upper block? Force transfer to the upper block. Force transfer to the upper block, F is equal to mu k mg, which is equal to 0.5 into mu k m value 2 into g value 10. So it will be 5 to the 10 newtons of force is transferred to the upper block. See, as this block is moving in this way, its friction will be this way. And on the top block, the force, whatever the pulling force, will be this way. This is 10 newtons of friction and this is 10 newtons of friction. Now it is experiencing another force of 2 newtons here, he has given. So net force will be 10 minus 2 will be 8 newtons of force will act in horizontal direction. 8 newton of force will act in horizontal direction. Yes, next. Block of mass m laying on, okay, this is the story. Okay, the wedge is pulled with the acceleration a on right side with 2 meters per second square. That is also given. Okay, let me take another color. Yeah, acceleration a is equal to 2 meters per second square as shown in the figure. The minimum value of quotient of friction mu is equal to question mark. Tan alpha is equal to, they have given as 1 by 5. Okay. So the blocks remain stationary. Fine. Here the concept I have to tell you, whenever the wedge is pulled with acceleration a, then it experiences pseudo acceleration a like this. So there will be a force ma in this direction. So that force I will write instead of acceleration. If wedge is pulled with acceleration a, then it will experience a pseudo force ma. That ma can be resolved into two components. One is this way, one along the plank. So if it is alpha, then this will be, if it is alpha, this will be alpha, na? Yeah. This is what we can call as alternate angles. So this one will be alpha, na? Alternate angles. So this will become alpha. See, if it is one line and if it is another line, and this is, and this one and this ones are alternate angles. So that is alpha. So obviously this component will be ma cos alpha, and this is ma sin alpha. Mg is as usual, that also I will mention with another color, mg. This is mg and this is one component, this is another component, and friction will be backwards. This is alpha, so this is mg cos alpha, this is mg sin alpha, So what are downward forces? Downward forces are mg sin alpha plus ma cos alpha. Okay, what are upward forces? Upward force is friction force, that is equal to mu n. Mu n is mg cos alpha minus ma sin alpha. Yeah, so it's under balanced condition. That's why both are equal. In that context, m can be cancelled and g not everywhere. Okay, so I can write g sin alpha plus A cos alpha by G cos alpha minus A sin alpha is equal to mu. So cos alpha can be taken common and cancelled, so that it will be G tan alpha plus A by G cos alpha cancelled minus A tan alpha is equal to mu, and you can substitute the numbers. G into tan alpha value 1 by 5 and plus A is 2 by G value 10. Here also 10 I will write. Bigger question, huh? Diagram must be understood very carefully. First resolution only new for you. The second G resolution you know. Minus A value 2 into tan alpha 1 by 5. So 5 will go 2 times, 2 plus 2 4, 4 by 10 minus 2 by 5. So after some simplification 5 by 12. Yeah, 5 by 12 will come. This is 5. Yeah, we'll go to the other question. An inclined plane making an angle 30 degrees with the horizontal. Where is that? Okay. 30 degrees with the horizontal. Write slowly. Theta equal to 30 degrees. Next. In uniform electric field, fine. E equal to 100 volt per meter. Fine. As shown in the figure. A block mass M equal to 1 kg. M is equal to 1 kg. And a charge 0.01. Q is equal to 0.01 coulombs is allowed to slide from rest to rest from a height h is equal to 1 meter. Electrical things I am writing right side and normal things one side. If quotient of friction is 0.2, fine. Then the acceleration of the block is nearly acceleration question mark. See here also, in the direction of field, it will experience a force. This will be EQ, force. EQ. Force is in the direction of the field. Can be resolved into two components. If it is theta, then this will be theta. Yeah, geometry, simple geometry must be known. So it is cos component, is sin component. I'll write here EQ sin theta. This will be EQ cos theta. Where should I write here only? EQ cos theta, I'll write. Yeah. Next. MG resolution is as usual. I'll do with blue color. MG resolution. MG. And this will be mg cos theta. This will be mg sin theta. Mg sin theta. Wow. What is he telling? What is the acceleration? Allowed to slide down. So acceleration A is equal to friction will be upwards. Like that you can take. Net force. Net force means downward force is mg sin theta. Downward force mg sin theta. Minus upward forces. Upward forces, what are they? All are friction forces, yes. What are the forces upward direction? Upward direction force is 1 EQ cos theta is there. EQ cos theta is there. Next, plus mu n, mu into n. N is EQ sin theta. EQ sin theta plus mg cos theta. I repeat, downward force is mg sin theta. Upward force is EQ cos theta is there, frictional force is there. EQ cos theta and frictional force, both are upward forces. So acceleration equal to net force by total mass. So this will be mg sin theta minus EQ cos theta. I am splitting EQ cos theta. Later you two can substitute. Q mu into EQ sin theta minus mu into mg cos theta. Friction will take two things here, mg cos theta, EQ sin theta, friction will be taken by mass. Now you can substitute the things. M value 1 kg only, so no need to consider. G value 10, okay. 10 only, yeah, G value 10. 10 into sin theta, sin 30, 1 by 2 minus E value 100, okay, 100. Q value 0.01. Easy numbers, root 3 by 2 minus mu value. I don't want to waste time after substitution. You can simplify fast. Okay, 0.2 into this value will be 1 only, because this total value is 1 only. Sin theta 1 by 2 only. This is 0.2. Okay, minus mu value is 0.2 into mg value is m is 1 only, no? So g value into 10 into root 3 by 2 by 1 only. So I no need to. So acceleration A is equal to, I did it, you see, 2.3 meter per second square. Yeah. SARS will have some advantages. Okay, next. Car is moving in a circular horizontal track of radius r is equal to 10 meters with a constant speed v is equal to 10 meter per second, and Bob is suspended inside the roof of the car with the length of the string is equal to 1 meter. The angle made by the theta is equal to how much? Okay, if the car is accelerated, then it will come back like this. So in this case, what is this? Circular. Okay, fine. A car is moving in a circular horizontal track of radius r is equal to 10 meters. Okay, and then with the help of a constant speed. Okay, so what is the force here? mv square by r. mv square by r. Constant force, no? That's why velocity, right? That's why mv square by r. This is mv square by r. This is mg. So as previously we have discussed, tan theta is equal to f by mg. Okay, f is equal to mv square by r. mv square by r into mg. mm gets cancelled, it is v square by rg. Tan theta v square by rg. Tan theta is equal to v square 10 into 10 by r 10 radius. Okay, 10 into g value 10. Okay. So everything 1. Okay, theta is equal to pi by 4. So option pi by 4. Next, one end of a string of length L is connected to a particle of mass m and the other to a small peg of a smooth horizontal table. If the particle moves in a circle with speed v, the net force on the particle directed towards the center. I repeat, one end of the string of length L is connected to a particle of mass m and the other is to a small peg on a smooth horizontal table. Smooth horizontal table, string, particle. Okay, so tension will be like this. And mv square by r will be like this. mv square by r will be like that. So centrifugal force. So it is this centered system, particle centered system. Okay, then the net force on the particle is equal to, net force on the particle is equal to T minus, but this is wrong. Why? Because this is a pseudo force. This is a pseudo force. The force acting on it, real forces whatever acting on that, F is equal to T only. That only supply necessary centripetal force. Supply necessary centripetal force. So force acting on it is T, tension. That only pulls the body towards the center. That's it. Next. A block rests on a rough inclined plane making an angle 30 degrees. Inclined plane, picture on, okay. A block rests on a rough inclined plane making an angle 30 degrees. Theta is equal to 30 degrees with the horizontal. The quotient of static friction between the block and the plane is equal to 0.8. If the frictional force on the block is 10 newtons, F is equal to 10 newtons. Mass M is equal to how much? A block rests on a rough inclined plane making an angle 30 degrees with the horizontal. The quotient of friction is 0.8. Here a small correction. We need to keep in mind that the body is ready to slide. Then only we can do. Otherwise, we can't do it. So ready to slide you can feel, then you can. F is equal to 10 newtons. So here frictional force is given, fine. The frictional force F is balancing mg sin theta, right? So 10 newtons is equal to mg sin theta. What is m? That I have to find. G value 10 into sin theta, sin 30 degrees 1 by 2. Yeah. 10 gets cancelled by one time. So m is equal to 2 kg. If he won't give frictional force, you can take mu mg cos theta if and only if it is ready to move, otherwise you can't take. Okay, I thought like that, that's fine. Oh, end of the show. So these are the good model questions based on Newton's laws of motion. The next session we'll discuss other topics. Bye.